but it works on my machine. Ah, the classic phrase. If you're a developer, you've said it, you've heard it, you've probably screamed it into the void at 2 a.m. It's the 4-word horror story that means hours of your life are about to disappear. Well, today we're talking about Docker, the tool designed to make that phrase completely, totally extinct. And man, this quote from a developer on Reddit, it just hits the nail on the head, right? It perfectly captures that pre-Docker chaos. You'd go in, you'd fix one little library, and bam, 2 other services would just fall over. It was this constant, infuriating game of whack-a-mole where you spent more time just keeping the lights on than actually building cool stuff. And that frustration, it has a very real cost. Get this, some studies have shown that dev teams can lose up to 40% of their time. That's nearly half a sprint, just wrestling with these exact kinds of environment problems. That is a staggering amount of time not spent innovating, but just trying to get a stable foundation to work on. So what was this old way that caused so much pain? Well, it was pure manual chaos. Every single developer had to install every database, every library, every little tool directly onto their own laptop. And you know how that goes. Mac, Windows, different versions of the same software. No 2 machines were ever really the same. But, out of all that chaos came a truly brilliant solution: containerization. And the tool that brought this incredible power to all of us is, of course, Docker. It's kind of the hero of our story today. So, what is Docker really? At its heart, it's a way to bundle up an application with all of its dependencies. And I mean everything: the code, the runtime, system tools, libraries, the whole shebang. It all gets packaged into one neat, tidy, portable little unit called a container. The magic word here is portable. Now, to really wrap your head around Docker, you only need to get 2 core ideas. Seriously, everything else builds on top of these 2 things: images and containers. So let's break them down. This right here is probably the best and simplest analogy you'll ever hear for this. An image is the blueprint. It's a read-only template with all the instructions. A container? Well, that's the actual house you build from the blueprint. It's a live, running instance of the image. And the cool part? You can take that one image and spin up dozens of identical, perfectly isolated containers from it. Now, a lot of people ask, hey, isn't this just a fancy virtual machine? And the answer is not even close. This really shows the difference. A VM has to virtualize the entire operating system, which makes them huge. We're talking gigabytes and super slow to start up. A Docker container, on the other hand, just virtualizes the application layer and shares the host OS. This makes it incredibly lightweight, megabytes instead of gigabytes, and they start up practically instantly. It's a total game changer. Okay, so we know what Docker is. Now for the fun part. How does it actually work? Well, it all comes down to creating a sort of recipe, a perfect recipe for your application's environment. And that recipe is a simple text file called, you guessed it, a Dockerfile. This file is your step-by-step blueprint. You literally write down every single instruction needed to build your application's environment, and Docker just follows it perfectly, every single time. And the instructions themselves are super straightforward. You start from a base, like an official version of Node.js, then you copy your own application code into it, you tell it to run whatever commands it needs to install your dependencies, and finally you give it a CMD, the default command to kick off when the container starts. See, it's just a logical step-by-step process. And once your Dockerfile recipe is all written up, it literally takes just 2 commands. Docker build reads your file and creates that portable image, and then Docker run fires up a container from that image. That's it. Build it once, and then run it absolutely anywhere that Docker is installed. Okay, so you know what it is, you know how to build a basic container, you're ready to go, right? Well, almost. Using Docker in the real world means using it smartly, and maybe most importantly, securely. So let's cover a few essential best practices. You know the old saying, right? With great power comes great responsibility. Docker makes things incredibly easy, which is awesome. But we have to be mindful of a few key things to make sure our applications and our data stay safe. So here's the first big gotcha you're probably going to run into. Containers are designed to be temporary. That means when you stop and remove one, any data that was created inside it, like a database file or user uploads, is just gone forever. So how do we solve that? The answer is Docker volumes. Think of a volume as a special folder that lives on your main computer, but it's managed by Docker. You just tell your container to use this volume. Now, anytime your app writes data, it's actually being saved in the volume, completely outside the container. So you can delete the container, update it, whatever. Your data is totally safe.
Next up, security. Now look, Docker itself provides a ton of isolation right out of the box. The most common security risks don't actually come from Docker, but from how we set up our containers. A simple misconfiguration can open a door we didn't mean to.
So, here are a few critical rules to live by. First, the biggest one of all, never, ever expose the Docker daemon socket to a container. That's like handing over the keys to your entire machine. Second, always run your app as a non-root user inside the container. It's a simple change that hugely limits what an attacker could do. Also, lock down the container's capabilities to only what it absolutely needs. And finally, if your app doesn't need to write files, make its file system read-only. These simple steps have a massive impact on security.
Okay, so you follow these practices, you get the hang of it, and this is where the magic really happens. Docker isn't just another tool. It completely transforms your entire development workflow. So what's the big payoff? Well, you get total consistency. What runs on your machine is exactly what runs in production. You get incredible speed. A new developer can be up and running in minutes, not days. And maybe best of all, you get confidence. You can deploy your application knowing, without a doubt, that the environment is perfect every single time.
Ultimately, it all comes back to this one beautiful promise. This is what Docker delivers. You can finally, once and for all, eliminate that dreaded phrase from your team's vocabulary for good. So, with all those hours of configuration nightmares and environment debugging finally behind you, there's really only one question left to ask. Your environment is solved. What amazing thing are you going to build next? Thanks for tuning in.